Okay, let's get started. So first of all, welcome to the talk, and thank you for coming to our talk. Today we are going to talk about cell. It supposedly is supposed to serve as a fill guide to integrating cell in the Kubernetes Codebase, and I know I said supposedly twice because this is the first one I'm giving for this KubeCon. My name is Priyanka Saggu. I work at SUSE as a Kubernetes integration engineer in the BCL department, SUSE Linux. I'm also one of the technical leads for Kubernetes SIG contributor experience, and I've been part of other SIGs in other capacities for some time now.
Yeah, hey everyone, again thanks for coming to our talk. My name is Sreeram Venkitesh. I work at DigitalOcean as a senior software engineer, and I'm also part of the release team for the past, I've been part of the release team from 1.29, and I'm also an active contributor in SIG node.
So this is our agenda today, and I really want to highlight our agenda is driven by our about a 1 year journey of us learning cell from like very scratch. We did not know anything about cell to now when we are working on a cell-based KEP, which is KEP 495. So we are driving our agenda on how from the time we started learning about cell to what we are doing today. And fun fact, this started in the last KubeCon EU itself. So the first thing we'll cover is what is cell, and then we'll see cell in Kubernetes, what all work is happening related to cell in Kubernetes today. We'll also do a very quick run through how cell works, just to build a mental model of how actually cell works. And then once we have that mental model, we'll see what kind of work has happened in cell from the very beginnings, from its inception with the first ever KEP that introduced cell to now what is happening in the cell space in Kubernetes project today. Finally, we'll end with just a few overview of KEP 4595, which is the KEP that Sreeram and I are working on. It's about adding cell support to CRDs, one of the other areas in CRDs, which is CRD additional printer column. So with the agenda set, we just want to highlight the last two are going to be the areas that we are going to drive most in this talk. Before we also get started, there are some acronyms we are going to use a lot during the slides. So other than cell, CRD, KEP, which are just the full forms, and the full forms are written in front of them. When we talk about cell upstream, we will mean the Google cel-go package or the Google cel-go repository. So whenever we are talking cell upstream, we mean that. With that, if there is anything else you find during the slides that is not covered in the acronyms, you can just let us know. We'll make sure we record them in the handout notes, or we can discuss them. So let's get started with what is cell. By the verbose from the resources in the footnotes, cell stands for Common Expression Language. Originally, it was developed by Google. There is a lot of contribution happening. Cell is a known Turing complete language. It's ideal for lightweight expression, has a C-like syntax, but that is all the verbose we picked up from the resources there in the footnote. We also don't understand everything that's written here. So to us, cell, when we talk about cell, we mean some expression that looks like this. So the first one, where we are trying to figure out whether this string Alice is starting with A, or in the next one, which is where we're checking if this array of tweets contain the messages, tweet messages, either like 280 size or less than that. So that is how we understand cell today with these expressions. But in Kubernetes, you would find cell something like this, the expressions that are here. And I'll read the very first one. It says, this one is to validate that 3 fields defining replicas are ordered appropriately. So there is a lot of them here. And more, there are different libraries, cell libraries within Kubernetes. the regex library, the URL libraries, everything is available in that footnote link. That is how we understand cell today, these expressions. We'll go into them. And not just the things that we showed in the last screenshots. That is not the only thing you can do with cell. You can leverage cell to write your own expressions and to serve your own use cases. So how are we doing cell in Kubernetes today? We'll first try to learn about them through some stats. Sreeram.
Yep, thanks, Priyanka. So we are going to look at some metrics to show how cell is getting more popular in Kubernetes today. So this is a screenshot of all the Kubernetes enhancements proposals, which you can find in the Kubernetes enhancements repo. So if you search for cell in the issues tab, these are all the KEPs related to cell which we have today. And out of all of these, the one at the very bottom is the one that introduced cell to Kubernetes in the first place. And we'll go into more detail into that, but once that KEP was generally available, now cell is being used in a lot more places, and there are a lot more places where we can introduce cell. So looking at issues in the Kubernetes repository, there are 6 pages of issues which has got something to do with cell, and the latest issue was opened 18 hours ago, which is when we took the screenshot, which is a couple of days back. And we also have a channel in the Kubernetes Slack workspace for cell and discussions related to both using cell and developing cell in Kubernetes. So you might be interested in that. Also, we wanted to give a shout out to a recent CV which was reported, which is something to do with Git repo volumes. And one of the suggested ways to mitigate the CVE was to use validating admission policy. So validating admission policy uses cell rules to write custom validation rules. Instead of using a validation webhook, we can do that natively in the API server with validating admission policies. So we wanted to give a shout out to that. Now we'll look at how cell works. So we've been talking about cell, and we've been talking about cell expressions for some time now. So we want to give a quick overview of what cell is and how it works in terms of code. So this is the a bird's eye view of what happens when a cell expression is evaluated. So we first define an environment where we have all the variables that we need to work with, and we compile the cell expression against this environment, and we'll get an abstract syntax tree. And this abstract syntax tree can be converted to an executable program, which we can execute with all the inputs that we want to run the expression against. So we'll look at the example that we showed earlier, and we'll actually go through all the code that does this. So I'm going to be writing this in Go. So first, what we do is we'll import the Google cel-go package. Once we do that, we have access to the cell package which we can use to create a new environment. And here I'm defining a new variable called name, which is of type string. So once the environment is created, we can compile our expression in this environment, and which is what we are doing with env.compile, and we pass the cell expression name.starts with the character A. And this compile call would compile the cell expression and return an AST, or it would return a list of issues if the compilation went wrong. So env.compile is actually syntactical sugar for env.parse and env.check, which are 2 different functions which are available in the package. And what we do in each of these steps is env.parse would check if the actual cell expression is of right syntax, and env.check would do type checking. So if we try to do if we try to call a macro function which is not applicable to a string type, then it would throw an error. It would throw an error at that check stage. So you can write these functions individually, but env.compile just does that for you together, and it's more easier. Once we get the AST, we can convert it into an executable program with env.program, and we'll get this program value, the program itself, which we can then we can call program.eval and we will pass the inputs. So in this case, the variables that we've defined for this environment is just a string variable called name. So we will pass that, we'll pass the name in the program.eval call, and the cell expression would be executed against our input. And in this case, since the name is Alice, which starts with A, we get the output of true. Yeah, now we'll see how Kubernetes is used in, cell is used in Kubernetes today.
Yeah, so this is the part where I mentioned during the agenda, we want to see how did cell evolve from the very beginnings when cell was integrated for the first time in Kubernetes to now what we have, what is happening related to cell in Kubernetes today. So cell was introduced to Kubernetes almost 10 releases back. It will be exactly 10 releases back in April with 133. So cell was introduced in Kubernetes 123 with this KEP number 2876. What this KEP did was adding cell-based validation for CRD schema. And you can read more about that in the kubernetes.io blog below. And there is also a link to the KEP itself that can give you the entire documentation about what that KEP 2876 brought into the cell. But here is like just a gist of what really happened. So the first thing that happened during Kubernetes 123 was people who worked on 2876 KEP brought the entire logic of cel-go from the Google repository within Kubernetes, but this time it was housed in CRDs. So we brought over the code. The intention was we wanted to make cell work with the Kubernetes resources or Kubernetes objects. So we brought those wired off code first, and then and this is another PR. This is the implementation PR for KEP 2876. The one comment that's highlighted there. This is where we started using the cell code we imported from the cel-go with CRDs. So what really happened in this commit was what Sreeram explained in the slides before. We created the environment to work with cell. We wrote our compile and parse functions, and then we started using those to compile our own custom expressions. But what was happening this time was cell was unable to understand Kubernetes objects. So cell was able to understand our resources that we submit using kubectl. Cell understood those types. And we first did that under gates. What was the use case here was, so I think I can explain that in this slide. So this is like a snippet of CRDs, and you can see under the spec, this field called X Kubernetes validations was added as part of the KEP 2876, where you can write some validation rule with cell, and whenever we are submitting the crd.yaml to API server, if this validation rules does not validate, then the CRD won't be able to, it won't be created. And we'll get that message back as an error. So this is that cell in action for the first time in CRDs. But this was added like first to Kubernetes CRDs. I think this is 2022. Now this PR then made cell available beyond CRDs. So we moved from just housing the CRD logic or CRD code that we were maintaining for Kubernetes from CRDs to API server. So this was the very first step to extend cell beyond CRD. And what happened then was, since cell was the first class citizen API server after this PR, more and more cell-based KEPs started to come up in other areas of Kubernetes itself. So then we had more KEPs like KEP 3488, cell for admission control. Here we can see cell was then later used for creating this new kind, validating admission policy. This is like an alternative to the traditional webhook admission webhook counterparts. And also now we recently, I think 2 releases back or something, we had mutating admission policies also based on the cell. So where we use cell expressions to check whether something, yeah. So here we are checking whether some things are missing, and if they are missing, then we are like mutating them. We're creating resources using that mutation patch type below. So, and that happened with KEP 3962. Not only we build up features based on cell, eventually cell was also being developed or like extended within Kubernetes. So cell got new custom DeclTypes, or we can say cell types. Like we were importing string type or int type, or the we can understand them as data structures from the cell itself, but now we are able to define our own Kubernetes specific DeclTypes for cell. So we now have cell DeclTypes for IPs or CIDRs or things that are being used in Kubernetes on a day-to-day basis. So there are two links here. The first one where you can is a directory under API server, where you can find out how the IPs or CIDRs or quantities, formats, and URL cell types are defined. And then the other one is another semver type that was defined as part of the DRA cap. I think this is a screenshot of the same thing. And then, so that is what is happening about cell. There is just, these things are just recorded in KEPs or issues or messages. There are a lot of requirement that are coming from the community as well. We forgot to add it here, but there is also a cell wish list issue in Kubernetes repo. We'll try to get an issue linked to that. So if you have like more use cases to cell-based solutions, people are like now wanting them to be implemented in Kubernetes space itself. So there is a KK issue to get community feedback. Okay, so with that, we can now move to the KEP 459 itself, cell for CRD additional printer column. That is the KEP that we started working on after we learned about cell, and we read a lot of cell-based work happening in different areas of Kubernetes, and we eventually tried to make use of cell in CRDs, different areas.
Yeah. So now that we've established that cell is an upcoming area in Kubernetes, we want to talk about what we are trying to do with cell. And yeah, so we are trying to add cell to additional printer columns in custom resource definitions, and we'll try to explain what we are, like the need for why we want to do this. So today, if you want to create a custom resource definition with, if you want to create a custom resource definition where you write, like where you define additional printer columns, which would be printed when you query for your custom resource using kubectl get like my CRD, my resource. Like if you do that, these are the like this is the only way with which you can define these custom columns today for CRDs, and the only way which you can define these columns are using JSON path. So the earlier slide, this has the output of kubectl explain additional printer columns, and we can see all the fields that are there in the API. And the JSON path is the only way with which we can define what data we want to show as part of the custom resources. So JSON path works well for querying data, but if you want to do like complex querying, like if you want to have a conditional statement, like if a particular field is present, then show this value, or if it is not present, then show something else, or like if you want to work with data that is like more complex, such as arrays or a list of IP addresses or things like that, you are not able to do it easily with JSON path today. So there are a lot of issues which have been created in the past where this limitation was addressed, and people were discussing ways to extend JSON path. Like on the right hand side, somebody wants to use the timestamp field to calculate the duration, which we are not able to do with JSON path today. We have a bunch of these examples of issues where people are facing limitations with JSON path, and this is an entire list of all the issues that we've come across where people want support for conditionals or support for working with arrays and so on. So now, given that this is not possible with JSON path, people have also tried to solve this with JSON path, like adding array support to JSON path and things like that. But that even though work has happened in that area, that has not been merged yet, because as mentioned by Nikita on this comment, it is not, given the complex nature of what we are trying to do, it is not like safe to extend JSON path to be able to do all of this. So what we are trying to propose, what we are proposing with KEP 4595 is that we add a new field along with the JSON path, which would be mutually exclusive. So you can have additional printer columns defined, which define the rule using JSON path or an expression. And the cell expression would use the CRD schema as the input, and you can write expressions to write your own custom additional printer columns. So the expression would be compiled and run in the Kube API server. So all of that would run natively, similar to how JSON path is executed in the API server today. So this is what the explain output of like additional printer column would look like after we've implemented this. So we have a new expression field which is similar to JSON path, where you can define a cell expression. And this is our local build of Kubernetes where we've added the support. So now I'll try to give a quick demo of what we have. So I have a CRD. I have a simple CRD called shirt, which has like two fields. It has a like a color field, which is of string type, and we also have a sizes array, which is an array of integers. And whenever I print these shirts, I want to do complex expressions based on these columns. So I have these three additional printer columns defined. The first one is a traditional additional printer column, which is defined using JSON path, and we are this should be color. We are querying the data directly using JSON path, and we are printing the color of the shirt. But I want to do complex, since the second field of sizes is an integer array, I want to be able to do complex operations. So in the second additional printer column, what we are doing is we are checking if sizes is present, and if it is present, then we print that array, or if it is not present, we print an empty array. And this expression field, the value that it takes, this is a cell expression. And we also have another additional printer column which checks if the sizes array is present or not, and if it is present, then we print a value of true or false. So this sort of complex operations are not possible with JSON path today, but we are trying to do this with cell. And for my example, these are the three custom resources that I'm applying. The first shirt has a sizes array and the color of red. The second one also has a sizes array, but in the third shirt we don't have a sizes array because that is an optional field. So once we apply the CRD and once we apply all the custom resources, if I query for kubectl get shirt, I can see that it prints all the columns with all the values that we want. So under the hood, what is happening is that when I apply the CRD, the cell expressions that I've defined in the additional printer columns, they will be compiled. And when I apply the custom resources are applied, but when I query for the custom resources, there is a table converter.go file which actually queries the data from the API and generates this table. So whatever we are seeing here is generated by that particular table converter.go file. And there the cell expressions would be evaluated against the CRD schema, and we would be like this expression would evaluate for each particular custom resource. So in the third custom resource, since we did not have the sizes array, we have a value of false because has self.spec.sizes evaluates to false. And in the second column that we have here, since the third item does not have sizes array, if we were trying to do this with JSON path, it would have been empty, but now we can have like default, like support for adding default values. And I also want to show a different example. So I'm adding a new additional printer column where the expression checks if the color of the shirt is blue, and if it is blue, then it would return a value of true or false. And the column is named is color blue. So once I apply this custom, once I apply the change to the custom resource definition again, now if I query for the shirt again, I can see that there is a additional, like a fourth column that we have, which displays the output of this particular cell expression based on the color of the shirt. So only the third shirt has the value of true, since the shirt of that color is blue and all of the others are false. So this is a quick example of like all these cell expressions are kind of basic, but what we want to show here is that we have extended additional printer columns to work with cell, and now like you can write whatever cell expression is within the limit of your imagination and within the cell cost, and do things which were not possible previously. So all the issues that were like discussed in these slides. So in this particular column, the one with the timestamp, we can work. We can use the cell type for timestamps to calculate the duration, and arrays obviously work. We've already seen that. And yeah, these issues talk about using conditional expressions to like evaluate additional printer columns to one value or the other, which is also possible with cell now. Yeah, so these are the screenshots of the demo that I just showed. So we can see how we have the OpenAPI schema and how the cell expression is executed against this as the environment. And yeah, we can have like multiple additional printer columns which has either JSON path, which has the rule defined with either JSON path or the cell expression. And this is the output.
So just wrapping up, because we covered about we learned cell, but what resources we found useful when we were learning cell. So we tried to create a list of what we found useful, and actually I remember that I also included the wish list. So the first one is the langdef markdown document. This is where what is available with the cell upstream itself. Or this document is actually like a running document. It keeps getting updated whenever there are more things being developed or added in the upstream cel-go. So that's the cell language definition itself. We found it very useful to understand what cell was bringing to the table itself. We found the cel-go code lab. That was our first time understanding how this cell integrations happen in Go space. The entire code that Sreeram showed, from creating the cell environment to using cell compile functions for compiling and parsing and type checking, etc., eventually to evaluate your own cell expression. All that we learned while going through these cel-go labs. So I think it's about 10 or 7 to 10 labs, super useful. There is also this online cell playground. If you have your own expressions, you can try running them there. And the last second one, wish list of cell, that is a Kubernetes issue that's created by, I think it's being run by SIG API machinery folks. So there is a lot of discussion happening on what is available today, what is not available with the cells, or what is not possible or supported with cell today in Kubernetes, but good to have, etc., etc. So if you have more such use cases, you can go and write them as comments in the wish list itself. Or if you want to just have a chat with people who are working on cell-based features within Kubernetes space, so the API, the Slack channel is SIG API machinery cell dev on Kubernetes Slack, which is slack.kts.io. And we do want to give a big, huge shout out to Alex Zielinski, because this talk would not have been possible without Alex. Alex was the first person, I think, Sreeram, you met during KubeCon Paris, during the SIG meet and greet. Yeah. So Alex was very helpful in helping us build up the foundational, our foundational learning for cell. So the very first few months, he helped us, give us some sessions, and then that's how we got started. So also not just that, Alex has contributed to a lot of other cell areas within Kubernetes. So we took one, and the link to that one is below in the footer notes. With that, our handout notes for this slide is available from that QR code. And if you want to contact us, these are our handles on slack.kubernetes.io, or those are the emails. So with that, thank you so much. And I'll keep it here for the QR code. Okay. And also we can take questions. We can try our best to answer them. Yeah.
So one, thank you. I am one of the many failed attempts to get the list working before you, so thank you. I'm so excited about this. One request. It would be incredibly, one of the pain points for us is we could kind of make an array work before, but what was really difficult, I represent Gateway API. We have a list of addresses, which is usually 1 or 2, maybe 3. But what would be really nice is what we see all the time in upstream Kubernetes of and more, right? So I'm going to show 1, 2, like the first 2 things in the list, and then a few more. I know you can include cell functions in Kubernetes. I know we already do that. If we could have one just for that, it would be so useful. So just a feature request that, I know that wasn't really useful for other uses of cell yet, but for this, it seems like it'd be incredibly useful.
Firstly, thank you so much for mentioning that, because I'll take it in 2 parts. Yes, we will reach out to you later, maybe on Kubernetes Slack, to just write down what your request is actually like, and then maybe we can add a function specifically for that use case. But I do want to mention, we did not realize this feature was this important when we just started with this keb. It took us, I think, the whole of last year to slowly come across all those issues, and then recently we started seeing, oh, there is still more requirements for this particular requirement, this feature. So, yeah, it just happened by chance.
No, thank you so much. This is awesome.
Yeah.
I have one if we're doing feature requests, but I can put it on the issue as well. Cell-based field selectors for kube control, that'd be great.
Sorry, cell-based?
So there's field selectors on kube control right now, and if you could throw cell into that, that'd be great.
I think we have
it's already going? Okay, cool.
So thank you, and thank you. If you don't have any more questions, I'll just say give cell a try. If you want to learn, just maybe follow our journey through the resources we shared. It's not super complex. I do want to give a shout out to a lot of keb documentation, especially the very first one. Yeah, shout out to Joe. And shout out to CC and Joe Witz, JP Witz, yes. So I wanted to give special mention to the very first keb itself, because we went through a lot of those codes and a lot of comments to figure out what was really happening in the code. The Kubernetes validation keb was our basis to understand how cell is integrated into CRD today, and then we slowly made our way to the keb 4595 CRD for additional printed columns. So thank you so much for doing great documentation while also implementing the keb. Yeah. And with that, thank you once again.